Hello and welcome to the isomers video. Isomers are groups of compounds that have something in common, something that makes them different. So I put a bunch of isomers on this table in your note packet. I'm sorry, some of the structures got moved around a little bit, but what we can notice from any of these compounds, if you count the number of carbons, 1, 2, 3, 4, 5, 6, 7, 8, there's always 8 carbons in every molecule on this paper. Now, these molecules look a little bit different from each other. But if we go ahead and we count the number of H's in the first one, we'll notice that we have the formula C8H18. Because those 8 carbons are right in a row, this is called octane, all single bonds. If we look at our next molecule, you'll notice you only have 7 carbons in a row. We actually moved one into a branched chain, but if you count, you still have 18 hydrogens. This molecule is now called 2-methylheptane. However, it still has the same molecular formula, but the boiling point is actually a little bit lower. The next molecule up here is very similar. We actually just took that branched chain and moved it over one to give us 3-methylheptane. And that actually altered the boiling point as well. If you continue to look at the rest of the molecules on this page, you'll notice they all have that same molecular formula, the same number of carbons and hydrogens. However, they do have a different arrangement, which leads to them having different names and leads to them behaving differently. They have different boiling points. If we reacted these compounds, they'd actually react differently as well. These compounds are what are called isomers. Now, the reason that they're called isomers is because they have the same molecular formula. In other words, number of carbons, number of hydrogens is the same. The arrangement or the structure of those atoms is different. Isomers are compounds with the same molecular formula, but a different structural formula. Same number of each atom in the molecule, different overall layout. Because of the different molecular arrangements, these compounds are going to have different physical and chemical properties. So I gave you the boiling points of those other molecules. Those are physical properties. Those are all different for each of those compounds because their atoms are laid out differently. Here's an example. Isomers do not have to be hydrocarbons. So the example ethanol versus dimethyl ether here, you'll see that both of these molecules have 2 carbons and 6 hydrogens. This is not specifically in your note packet, but I wanted to show it to you because you can kind of think about their behavior. If you breathe around ethanol, which is drinking alcohol, you'll be fine. If you breathe around dimethyl ether, it will make you pass out. So I wouldn't necessarily drink dimethyl ether either. I'm not exactly sure what happened there, but it does tend to vaporize really easily, has a very different boiling point, and also has different reactive properties as well. So by laying out the same number of atoms in a different way, they act differently.